Bismillahirrahmanirrahim. Assalamu alaikum. Let's start direct and inverse proportions. It's a chapter 1 of D2. Initially, I'm going to start direct proportions. So, what is direct proportion and how we can understand direct proportion? So, for that, the quantities are said to be in direct proportion, or quantities that vary directly are those quantities either they increase together or they decrease together. I mean, if one quantity is increasing, other is also increasing. If one quantity is decreasing, other is also decreasing. Now suppose if y and x are two quantities, right? And if y is directly proportional to x, then we may write it like this: x is directly proportional to y is directly proportional to x. It means that if x is increasing, y is also increasing. If x is decreasing, y is also decreasing. So this is the way to say that y is directly proportional to x, right? Now to remove this sign of proportionality, what we can have? We can have it like this: y is equal to kx. Okay? Now, it is same as this, but it is also like this, that if x is increasing, y is increasing. If x is increasing, y is decreasing. Then what is this k? The k is constant, or constant of proportionality, because, and why do we need this constant? It's because that it is not necessary that the y is increasing at the same rate as the x is increasing. So this constant is basically here to determine relationship between y and x. It is true that y and x are directly proportional. If x is increasing, y is increasing. X is decreasing, y is decreasing. But are they increasing at the same rate, or they increasing or decreasing at a different rate? So for that matter, we have this constant k, which determines the relationship between the two directly proportional quantities, right? So we'll come back to this constant later, but we can also write it like this: y over x is equal to k. That means that this is the ratio of the two quantities. Okay? If the two quantities are increasing or the two quantities are decreasing, they are increasing or decreasing at certain ratio. So this is that ratio. We'll come to this k later, but first let's take this ratio. This is the ratio for the direct proportionality. Let's take an example to understand how this direct proportionality ratio is working. Okay? Suppose a car covers some distance covered, and liters of petrol use. Let's say the car covers 45 kilometers and it uses 5 liters of petrol. What if the car has to cover 80 kilometers? How much petrol is needed? So you see that this is the case of direct proportionality. More distance you are covering, more petrol is required. Less distance you are covering, less petrol is required. So how are we going to apply the ratio of the direct proportionality? So what are we going to do? It's like this. As I said that y over x is equal to k. I'm going to use this same ratio to find out what liters of petrol is required to cover the 80 kilometers of distance. For that, what I'm going to do, y1 over x1 is equal to y2 over x2. It is because that this is the ratio. If the two quantities are increasing or the two quantities are decreasing, they have the same ratio, right? And for that matter, if they have the same ratio, we can equate the same ratios. So what are we going to do? This is y1, this is x1, okay? So 45 over 5 is equal to, now what is this? This is y2. So y2 and we don't know this, so it is still x, okay? So what we are going to do, 45x is equal to 80 into 5, so x is equal to 80 into 5 over 45, which is equal to 80 over 9, so approximately it is 9 liters. So if you want to find exact, it is something in 8 point something, but approximately it is 9 liters, because 9 nines are 81, so it is approximately 9 liters. So you see, the more distance you are covering, more liters of petrol is needed, right? Less distance you are covering, less liters of petrol is. So it's a case of direct proportionality, and we have applied the ratio thing to calculate this value, right? So let's do one more example and apply the same method of ratios to find the unknown, right? Okay, now we are going to do the second example. Suppose the quantity of chocolates you can buy for certain cost. Let's say you buy 5 chocolates for $2, right? And if you have $8, you want to spend $8 to buy some chocolates, what is the number of the chocolates you can buy? Okay? And for that, let's apply the same ratios. y1 over x1 is equal to y2 over x2. What is this? y1. What is this? x1. So it is 5 over 2 is equal to, what is this? y2. What is this? x2. So y2 over x2. x2 is known, okay? So we have to find this unknown here. What are we going to do? Y is equal to 8 into 5 over 2. So is equal to 20. So you can buy 20 chocolates. More money you spend, more dollars you spend, you can buy more chocolates, right? So this was how the ratios of the direct proportionality is applied to find the unknown. Now coming back to that equation, y is equal to kx. To understand this, we have a very good example of let's say circumference of a circle. Okay, if we have a circle, we have a radius and we have circumference. What do we say? Circumference is 2 pi r, right? So circumference is equal to 2 pi r. Now what is this? Although they are two quantities, but 2 is a constant and pi is a constant. So constant into constant is a constant, right? This thing remains constant. Now, what the radius you have, the circumference is going to change. If the radius is increasing, circumference is increasing. If the radius is decreasing, circumference is decreasing, right? So it's a very good example that this constant is going to remain the same. We are always going to have this 2 into 22 over 7, but this r is going to change. And the change in the r is going to affect the circumference. Either the circumference will increase if the radius is increased, the circumference will decrease if the radius is decreased. Okay. Now coming to same thing, let's take a simple example. Suppose I have an equation y is equal to 2x. It means that whatever the value of x is, value of y is going to be doubled because it is multiplied by 2, right? So let's draw a graph for it and see what kind of graph we are going to have. So let's do that. Okay, we are going to draw the graph of y is equal to 2x, right? For that, first let's find out the values. If x is 0, y is going to be 0. If x is 1, y is going to be 2. If x is 2, y is going to be 4. If x is 3, y is going to be 6. Okay, if x is 4, y is going to be 8. Right now, so let's take, this is for the x-axis, this is the y-axis. So on the x-axis, this is origin, right? This is 1, 2, 3, 4, 5, 6, 7, and so on, right? Same way, 1, 2, 3, 4, 5, 6, 7, 8. Okay, now for 0, 0, the first point is this. Then for 1, it is 2. Then for when x is 2, y is 4. When x is 3, y is 6. And when x is 4, y is 8. Okay, let's join the points. So you see, this is showing it's a straight line, linear graph, and it is showing that the value, as the value of the x is changing, the value of the y is doubling, because our equation is y is equal to 2x, right? So whenever we have a linear equation, so we are going to have a straight graph between y and x. So this is showing the relationship between the x and y. So you see, if the value of x is increasing, let's say if I say it's 1.5, right? And I can easily calculate what value of y is going to be, right? So this linear graph is showing the relationship. Hope you got the idea, and we'll do more in the next session. Thank you very much for now.